So let's go over this. But let's see. If you're gonna take some notes on this, maybe for later, then use a pen now. Write in something different. Don't change your answers. Okay, so we need a sequence of. Okay, so make sure they're just taking notes and not changing their answers. Can you help me with that, Pollock? Also, just kind of monitor that a little bit. All right, so we want a sequence of approximations of changes in height. How are we going to get a change in height if we have what the change in time is 0.15, and these are our constant rates? So how are we going to express changes in height? dH is going to be m dx or dt, whatever we got, right? So here are the different rates, and then our dx or dt is always 0.15, right? So negative 0.75 times. That's the first change in height for the first interval, m dx. Then second interval, it's actually going to be the same thing because it's the same. It's the same rate, and now the rate changes to negative 0.5 in the third interval. And then in the fourth interval, the rate is negative 0.4, so m dx. And then the fifth interval, back to negative 0.75. So if you didn't get that, does that make sense, right? Changes in height, change in the dependent is m times change in the independent, right? This has been a major theme all semester. Yeah, question? I just said verbally. I said you'd only use your calculator for part B2. It's not bad. It's the same. I'm just writing it out explicitly. Yeah, because these have values, right? Each one of these has a value, so, and the values are equal to those. But I just mentioned that you should just save your calculator for the end of part B. Okay, write an expression for the series associated with the sequence. So how do we get the series associated with this finite sequence? What do you want to show? We're just going to add these up, right? Series is the sum of the terms of the sequence. Don't use sigma, right? We're just doing it like a second grader understands, right? So just going to add all those up. Okay, and anyone use your calculator and what did you get for that answer? Negative what? 0.4? Yeah. 0.4725. Someone else get that? Yeah, okay, good. So what does it mean? So now I asked you to find the, I guess I didn't ask you what it meant.
In part D.
Later in part D, so we'll do it now. So later in part D, I ask you, what does this number mean? In the context, right? Having to do with the flag. So what is it? Jesus knows, Megan knows. What do you think? So what would that, so those are our fancy words, in this case, meaning for what? When you say, the change in the flag's height. That's right. So this is like a net accumulation, right? It's an accumulation of little changes in height. So it says that the flag in that amount of time approximately went down by 0.4725 meters. Is that what you're going to say? Question? So there are 5 intervals, right? Mm-hmm. But I gave you 5 rates. So this rate then would be from 0.6 to point. See, these are the rates at the left sides of each time interval. Right, these are the rates at those time intervals. So then this rate would be for 0.6 to 0.75. Yeah. So all I'm saying was these are the rates at these times. So it's not this is talking about particular points in time, not intervals. So 0.6 is the left-hand side of the 5th interval, and that's the rate you're going to use. Yeah. Okay. Was there another hand? Someone? So this is accumulating by summing up all those changes in heights, we get the net accumulated change in height for the first, 0.75 seconds. So that would be part of the answer to D. Questions so far? Anybody having success so far? You had some success? A little bit, kind of. Okay, ask me. So if you weren't successful and you need to ask a question, don't hesitate. Does this make sense? Okay, the sequence of partial sums. So what's the first? So if you got some kind of sequence here, so maybe you got this wrong, but in part B, the important thing is that you just showed adding all those together. Okay? And then in part C, what is the sequence of partial sums? So what's the first term in the sequence of partial sums? This one, right? So we're thinking of the first one is negative 0.75 times 0.15. Now, what's the second partial sum? Add the first 2 terms, right? So add the first term. Add the first 2 terms. And then what's the third partial sum? Add the first 3, right? So it's going to be negative 0.75 times 0.15 minus 0.75 times 0.15, what? Minus 0.5 times 0.15. So this is 3 terms of a sequence of partial sums. Again, if you got the A wrong, but you showed the same pattern that you did the first term and the sum of the first 2 and then the sum of the first 3, then your C is correct even though your A was wrong. Questions on that? Any questions? Okay. So now let's look at, can I erase what I put up there? I don't want to. So we did that. We did part 1. We did D1. So now explain what's the meaning of, okay, so then this thing is a representation of a very important thing we've worked on a lot this semester. So looking at the first partial sum, the second partial sum, the third partial sum. Think about continuing to include more and more partial sums. What is that kind of like, or what is that a representation of? Anyone think they got this? What's that? Okay. So each one of those is net accumulation. So what about that sequence then? What about the sequence of all these progressing net accumulations? What is that like? Jesus, you going to say? No, because it's a sequence of different accumulations, right? I'm asking about the sequence. What is it kind of like? Yeah.
It's kind of like a function.
Right. Right. It's like the net accumulation function, right? It gives us, as you go down the sequence, it's giving you how much you've accumulated at different points in time. So did anyone say net accumulation function? Anyone say that? Kind of. A few of you. Yeah. So that's the idea, that this is just like a net accumulation function, looking at successive amounts of net accumulation as time goes by, right? You keep adding a little bit more on each time. But that's not addressing that it's a sequence, right? This is a list of values. So this list of progressing accumulations, that's what I'm getting at. So the list is like the function, right? Because the function gives us the value of accumulation at any point in time, right? It like tracks the change in net accumulation, right? So that's what I'm getting at here. Okay. Okay, now I'm gonna, let's see. Now we're going to, yeah. So now we're going to the next one. I'm gonna erase. Any questions about the first part? Okay, here we go. So now intervals are 0.1, and we don't have the rate values, but we have this function r sub h. Okay, so the first interval, let's just get started here. The first interval goes from what to what? 0 to 0.1. And how can you express that first rate then? If you're using the left-hand method, and the exact rate is r sub h. The function is r sub h. So how could you express that first rate? Some of you are saying in the front, r sub h of 0. All right, so then what's the sequence of constant rates at the left sides of these intervals? The first one would be r sub h of 0, then the rate for the second interval would be r sub h of 0.1, r sub h of 0.2, etc. All the way to, what's the last one? R sub h of 0.6? I'm sorry, 60?
No, one less.
Yeah, so it's going to be, so the 60th interval will start at 5.9. So that's extra, that would be extra bonus if you figured that out, right? So the last one would be r sub h of 5.9 would be from 5.9 seconds to 6 seconds, since we're doing the left side. Okay, so now we want the sequence of changes, right? We've got our rates, and how long are our intervals? What's our dx? 0.1. So to find each change, we do r sub h times 0.1. So that's the amount of change in height, m dx, right? M dx, rate times change in time. Last one will be r sub h of 5.9 times 0.1. How many people got that or were close on that one? Some, good. All right, that's hard. I mean, that's hard. You really got to know your function notation. Think about using function notation and then getting the MDX principle. Okay, so now we want to determine, so if I equals 1, 2, 3, etc., what formula is going to generate the ith term? So maybe let's look at this. So if I equals 3, how do we get that right there? So every term looks like what? R sub h of something times 0.1, right? They all are times 0.1. So the question is, the ith term, what changes on each one is this left side of the ith interval. So how do you get the left side of the ith interval? Anyone think they got it? Yeah. Almost. Okay, so like here's I is 3, so 3 times 0.1, but that's 0.3, not right. So yeah, so you're going to take I minus 1 times 0.1 or over 10. So you're going to take I minus 1 and multiply by 0.1 or divide by 10. And that gives you the left side of the ith interval.
That was the one where you made a list and it was really, I couldn't figure it out until I made that list. You know, of like term 1, 2, 3, 4.
Like you made a table.
Yeah, a table, and then it was just like super clear.
Did you had come up with this before?
Yeah.
Oh, nice. Okay, good. So you got this right?
Yeah.
Very good. Yeah, if you got this right, that's really good. Okay, so now the series. So how can we express that series? So either we show these added together, or now we can do, so we say in two ways. So now we want to incorporate the sigma, right? Sigma equals I equals 1, 2, 60. And what are we summing up? We're summing up those. So you just rewrite that. R sub h of I minus 1 over 10 times 0.1. That does it. So what, again, you see this and you think what? What do you think? You think this. See, when you see this right here, you think this plus this plus this plus, and so on until you reach that one, and then you're done, because we're stopping at the 60th interval. Is that the last question? All right, so what's the meaning of this sum, right? So in this situation, so that's a finite sum, meaning we could do that, and it would be a number, right? It would be a number. And what would the meaning of that number be? Anyone? What's that? Okay, change of height is an exact or approximation? She wants exact. Agree with that? It's approximate because our rates, yeah, we have the R sub h function as the exact rate, and we're like picking off these rates to be constant rates. So that makes it approximate, right? It's like we're making our step function out of R sub h. So we get what? The approximate change in height of the flag in the first 6 seconds, adding up the little individual changes, right? Okay, let's go on to just go right to number 2 in the back. So let's talk through that. So any more questions about the quiz questions?
I have one question.
Please.
So for H, I wrote, for the second way, I did the sum one. But for the second one, I feel like I did something probably wrong. So I put H of 1, and then I did H1 plus H2. I was supposed to do R sub H of 0.1, and then...
Show me after class. Just show me after class. All right, so flip over and work on, let's look at number 2. So let's read it together so we make sure. So a turtle is walking across your back lawn. Everyone has a turtle walking across their back lawn. So on day 1, he starts at the east end and he walks halfway across. And on day 2, he walks half the distance remaining to get to the west end. In other words, he walked 1/4 of the total length. Every day continue this way, always walking 1/2 of the distance remaining to get to the west end of the lawn. Is the setup clear? All right, so I read through and answer these questions. See if you can do these in 3 or 4 minutes. Okay, so I started doing it. So your sequence should be of distances is 1/2, 1/4, 1/8, 1/16, etc. And that the general formula is 1/2 to the I. Did you get that? 1/2 to the I. So on the ith day, his distance covered is 1/2 to the I. Okay, so then the sequence of partial sums then is 1/2, 3/4, 7/8, 15/16, 31/32. So the first term, the first 2 terms added together, the first 3 terms added together, first 4 terms, first 5 terms, etc. So what would the general so we can also do here we did a formula for the original sequence. Now we can do a formula for that sequence of partial sums now that we've added them up. So what are our denominators? It's the same as it was before, right? 2 to the I. So what about the numerator? 1, 3, 7. Isn't always 1 less than the denominator? So 2 to the I, and that number minus 1. What does the sequence of partial sums represent? So that sequence right there, that sequence of partial sums. So the original sequence represented how far he walks on a particular day, right? What does the sequence of partial sums represent for the turtle? Yeah, so like, great. So again, what concept is that like? Net accumulation of distance, right? This is like a net accumulation function, right? And on the ith day, what's the total change that he's made, right, since the beginning? So it's a net accumulation function. Okay, will he ever make it across? Yes or no? Will he ever make it across? Stay tuned next week. It's an exciting conclusion.